Hello ladies and gentlemen, what we're going to be looking at today is Lewis structures, which are also called structural formulas. So by the time you're done with this video, you should be able to draw the Lewis structure for just about any molecule that I'll give you in here. So let's get started. So just a little bit of review of the last video you watched, which was over molecular formulas. And so something that molecular formulas tell us is they tell us the number of atoms of each element in a compound. So an example of that would be something like CO2. Okay, CO2 is a molecular formula. H2O is a molecular formula. So what does CO2 tell us? Basically what it tells us is it tells us that we've got one atom of carbon and we've got two atoms of oxygen in every CO2 molecule. So there's a reason why there's a 2 behind the O. That tells us how many oxygens there are. And then if we don't see any subscript at all, for instance behind the C there's no number there, what that means is there's really a 1 there, there's 1 carbon and 2 oxygens. So we're going to need to know that information in order to draw our Lewis structures. So what Lewis structures are, or also known as structural formulas, you'll hear those words used kind of interchangeably. I'll generally refer to them as Lewis structures, but they could also be referred to as structural formulas. Well, what they tell us is, they tell us really the same thing that molecular formulas do. They tell us the elements that are involved. So in our last example, CO2, they tell us, oh, we've got carbon and oxygen. They tell us the number of each type of atoms. So in our last example, we had our carbon, only 1 of them. Oxygen, we had 2 of them. But what Lewis structures or structural formulas tell us that molecular formulas do not is Lewis structures or structural formulas will tell us the arrangement of the atoms in the molecule. So we're actually going to be like drawing something, and we're going to see the arrangement of atoms. And there's some rules that we're going to follow in order to do that. So this process, or these rules, I've given to you, or you should be able to follow a link on this video to be able to find those rules that I'll be using. I'll run through them on the slides kind of the first time around, but then when we start doing practice problems, I won't show you the rules anymore. I'll just trust that you have that note sheet close by so that you can follow along with the rules as I read them. So we're going to consider HCl. So this is a molecular formula. HCl, what it tells us is we have 1 hydrogen and we have 1 chlorine. And we're going to need to know that information in order to draw our Lewis structure. So here's the process that we're going to follow. The first thing you need to do is you're going to count the total valence electrons for the molecule. Okay? Then the second thing is you're going to figure out the number of electrons the molecule would have if each atom had its full octet. Remember, octet, the octet rule says that every atom wants to have 8 or 0 valence electrons. Well, in Lewis structures, what we're assuming is that every atom that we look at wants to have 8 valence electrons, and the only exception to that rule is hydrogen, and hydrogen wants 2 electrons. Okay? So, again, step 1, count all the valence electrons in the molecule. Step 2, count up all the electrons that the molecule would have if every atom had 8, or if we had hydrogen, it has 2. So again, we're looking at HCl. So the first thing we're going to look at is the valence electrons. Now, I've abbreviated that as VE. This is step 1 that was on the previous slide. Hydrogen, how you determine the number of valence electrons a molecule has is you just look at each individual element. Well, hydrogen is in column 1, so that means it has 1 valence electron. So hydrogen would bring 1 valence electron. Then chlorine is in column 7A, it's in the halogens, which means it has 7 valence electrons. So if I add those two up, 1 valence electron plus 7 valence electrons, that gives me 8. That's how I get my VE, or my valence electrons. Next thing that I do is I find my octet electrons. And again, that rule, that's step 2 on the previous slide, is that every atom wants 8, except for hydrogen, and it wants 2. So hydrogen wants 2, chlorine wants 8, I add those up, 2 plus 8 gives me 10. That's how I get my valence electrons and then my octet electrons. Next step that we're going to do is we're going to subtract our valence electrons from our octet electrons. In other words, we're going to do OE minus VE, and what that's going to give us is what's called our bonding electrons. These are the electrons that are tied up in the bonds of an atom, or excuse me, of a molecule. So after we do that, then we're going to divide our bonding electrons by 2. This will give us the number of bonds that we have to work with, and bonds are what connect these atoms together in our molecule. And so we'll do bonding electrons divided by 2. So let's look at that. So again, the third step on that previous slide, was do OE minus VE. So 10 minus 8 gives me 2 bonding electrons. Then my next step, step 4, was to divide my bonding electrons by 2. Well, 2 divided by 2 gives me 1, which means I'm going to have 1 bond. Okay? And here's the rest of our process. We're going to draw an arrangement of atoms that contains the number of bonds you found, and you need to follow these rules. Okay? Now, these rules are going to be followed 95% of the time. There will be some instances where they get broken, but I won't give you those instances. I'll talk about an example where they do get these rules kind of do get broken, but for the most part, you're going to use these rules. So hydrogen and halogens, want to bond 1 time, which means they're going to have 1 bond in between them. And I'll show you what that means here in a second. Oxygen elements will bond twice. Nitrogen family elements will bond 3 times, and then carbon family elements will bond 4 times. And what that means is if the element is in oxygen's column, it'll bond twice. So something like sulfur. Sulfur's right below oxygen, which means it also wants to bond twice. Another element that would be in the nitrogen family would be phosphorus, or P. That wants to bond 3 times. And then the carbon family would be anything in carbon's column. So carbon, silicon, those are ones that are going to want to bond 4 times. So keeping those rules in mind, remember we have 1 bond. Now, when you connect atoms together in a molecule, they have to be connected by at least 1 bond. Otherwise, if there was no bond connecting atoms, then they would just be able to float around, right? But a molecule means that they're all connected. So what I'm going to do is I have to place my bond to connect these 2 atoms. Well, the only place I can really do that would be right in the middle. So I'm going to put, these 2 bonding electrons. Well, how we generally represent that is with a bond. A bond, we just draw a line. What that shows is these atoms are connected through sharing of electrons. Okay, so I've added in my bond, my molecule is now together, and I have another step that I need to complete, and this is the last step. And the last step is to find the number of lone pair electrons. I will refer to those as non-bonding electrons, but you could see them referred to as either word. And how we find that is by subtracting the bonding electrons from valence electrons. So basically we're going to do VE minus BE. What's the valence electrons that we started with minus our bonding electrons. Then we're going to arrange these electrons around the atoms until our octet rule is satisfied. Remember, we said that every atom wants 8, except for hydrogen, it only wants 2. So here we go. So we need to take our VE, which is 8, minus our BE, which is 2. So 8 minus 2 gives me 6. What that means is I need to add 6 dots around one of my atoms. Now I'm always going to add non-bonding electrons around an atom, meaning I either have to add it around the H or add it around the Cl. So, and how we know what to add or how many to add is by looking at how many electrons each atom feels like it owns right now. So these electrons right here, remember there were 2 dots right here in between the H and the Cl. Hydrogen feels like it has those 2 electrons because they're close by. Remember, the octet rule for hydrogen is that it only wants 2. Well, these 2 electrons in the bond, it feels like it has control over. So hydrogen already feels like it has 2 electrons, which means it doesn't need any more electrons. Chlorine, on the other hand, it also feels like it has these 2 valence electrons, but the octet rule says that these atoms, every atom except for hydrogen wants to have 8. Well, these 2 electrons that are around chlorine, so chlorine feels like it has 2 electrons, which means it needs 6 more to get to 8. So these 6 non-bonding electrons that I have, I'm going to add around the chlorine to satisfy its octet in order to get it 8 electrons. So it would look something like this. And this would be my Lewis structure for HCl. Okay? So we're going to look at 2 more examples, and I just would encourage you to follow along, work through the problem with me on a scrap sheet of paper, and make sure that you're following along with the rules as well.
So here are the 2 examples that we're going to be looking at today. So here we have CO2. Now CO2 should be written something like this. Okay, so what we're going to do is we're going to start by calculating our valence electrons. So you look at each element, find where they are and what column they're in, and that will tell you the valence electrons. So carbon is in group 4A, which means it has 4 valence electrons. Then you look at oxygen, it's in column 6, which means it has 6 valence electrons. Okay, but there are actually 2 of them. So that means because of this 2 right here, I need to multiply 6 by 2. So basically what I'm going to have is I'm going to have 4 electrons from my carbons plus 12 electrons from my oxygens. And what that gives me is that's going to give me 16 valence electrons. So that means my VE is 16. Next, I'm going to find my octet electrons. So remember, the rule for octet electrons is we assume that every atom wants to have 8 valence electrons, except for hydrogen, and it only wants 2. So these 2 elements that are involved in this compound are carbon and oxygen. So they all want to have 8 electrons. So I'm going to have this carbon is going to want to have 8. Then this oxygen is going to want to have 8, but again, I have to take this 2 into account. So I'm going to have to multiply this times 2, which is going to give me 8 plus 16. That gives me 24 octet electrons. So I'm going to put 24 for octet electrons. Next thing I need to do is I need to find my bonding electrons. So again, to do bonding electrons, I'm going to do OE minus VE. So my octet electrons is OE, my valence electrons is my VE. So I'm going to do 24 minus 16. And that gives me 8. So that's how many bonding electrons I have. Next, I need to find my bonds. To find the number of bonds that I'm going to use in my Lewis structure, I am going to take my number of bonding electrons and I'm going to divide by 2. So I've got my 8 here, and I'm going to divide that by 2, which is going to give me 4. Which means the number of bonds I need to use in my Lewis structure, or the number of lines I need to use in my Lewis structure, is 4. Next, I'm going to find my NBE, also known as my non-bonding electrons. So my non-bonding electrons are my valence electrons minus my bonding electrons. So in other words, it's VE minus BE, which is going to be 16 minus 8, which will give me 8 for my non-bonding electrons. So if you wanted to, you could go through it in steps, and like after each step, you could start writing and drawing your element. I like to just go through and calculate everything right at the beginning. That way I'm done doing like all the math stuff, and now I just draw. So what you're going to use now is you're going to kind of use the rules for how many times elements want to bond, and that is on a paper or on a document that I gave you guys earlier in the unit, or if you don't have that paper, you can follow a link at the bottom of your screen or on your screen right now, and that will take you to the link for that document. And one of the rules in there is about how many times each element wants to bond. Okay, that's how you're going to decide what element goes in the middle. So for instance, for this compound, it's CO2. So we have a carbon and 2 oxygens. So if you look in that, it's going to say that carbon group elements, and again, carbon group elements are elements like carbon and silicone, or Si, they're going to want to bond 4 times. Then you've got the elements that are in nitrogen's group, they want to bond 3 times. Then you've got elements in oxygen's group, they want to bond 2 times. And then it says the halogens, which is group 7A, and then hydrogen wants to bond once. So the elements that want to bond the most number of times are going to be the ones that you put in the middle. So carbon wants to bond 4 times, so we're going to put it in the middle. Next, I have 2 oxygens to fit in. Now, remember, I have to connect my carbon atom to my 2 oxygens. So I'm going to do that right now. So I'm just going to go here and there. Now, each one of these lines that I just used, okay, those are represented, those are the bonds. But it said that I needed to use 4 bonds, and I've only used 2. So what I'm going to do right now is I'm going to use something that's called a double bond. which means I'm going to put 2 lines connecting my 2 oxygens. Now you might be like, how'd you know to do that? Well, here's how I knew. Remember the rules that I was just talking about how many times each element wants to bond? Well, we said that carbon wants to bond 4 times. So notice how it has 1, 2, 3, 4 bonds around it right now. Then I want you to also notice that oxygen wants to bond 2 times. And notice how it has 2 bonds around it. So I'm going to get rid of these numbers that I wrote, but all of my elements are bonding the number of times they want to bond. So that tells me that I'm good to go. So the next thing that I need to do, I've drawn an arrangement of my atoms. I've put in the number of bonds that I need to put in. The next thing that I need to do is I need to use my non-bonding electrons. Whoops. I need to put in my non-bonding electrons. So my non-bonding electrons are these 8 electrons right here, which means I need to put 8 dots around my atoms until their octet rule, or their octet, is full. Okay? So I'm going to draw some circles here. This oxygen feels like it has control of those electrons, and this oxygen feels like it has control of those electrons. Then my carbon feels like it has control of these electrons. So notice how each atom feels like it has control of, or the electrons are around them if they're like directly next to. So the number of electrons inside this blue circle here is actually 8. And the reason that it's 8 is because each bond is considered to be 2 electrons. So that means I've got 4 electrons on the left side of the carbon and 4 electrons on the right. So this carbon has 8. It's good to go. It doesn't want any more. However, my oxygen atoms, they have 2 bonds, right? So each one of those bonds is 2 electrons. So if I have 2 bonds and each one is 2 electrons, that means these oxygens only have 4 electrons each, which means they need to get to 8. So I'm going to have to add 4 dots around oxygen so that it has 8 electrons around it now, because now it has 4 from these bonds and it has 4 from these non-bonding electrons. And I'm going to do the same thing over on my left side. And there would pretty much be my Lewis structure. Now I'm going to try and get rid of some of this stuff here. You don't need to draw in those circles. I just did it more of as a representation. Looks like I'm not going to be able to do this, so I'm just going to redraw this so that I can so what I should be left with is a Lewis structure that looks something like this. And there's my Lewis structure for CO2. Okay? So we're going to try one more. So now we're going to be looking at CO, which is called carbon monoxide. So the first thing, again, that we do is we start with our formula and we start identifying how many valence electrons, octet electrons, and so on that it has. So carbon is in column 4, so each carbon has 4 valence electrons. Oxygen is in column 6, so each one of them has 6 valence electrons. So I've got those numbers in. So that's going to give me 10 total valence electrons. Then I'm going to look at my octet electrons. Again, every atom wants to have 8, except for hydrogen, and it wants 2. So carbon wants 8, and oxygen wants 8, which means my octet electrons is going to be 16. Then to find my bonding electrons, I'm going to do my octet electrons minus my valence electrons. So I'm going to do 16 minus 10, and that's going to give me 6, which means my bonding electrons is 6. Again, to find my bonds, I'm going to divide 6 by 2 because every bond has 2 electrons in it. So if I have 6 bonding electrons, that means I'm going to have 3 bonds. Then to find my non-bonding electrons, I do VE minus BE. So I'm going to do 10 minus 6, which is going to give me 4. So I'm going to add in my 4 non-bonding electrons at the end. So I'm going to start with my arrangement of my atoms. Well, since there's only 2 atoms here, I don't really have a central atom because I can't really put carbon in the middle since there's only 2. But I'm just going to start with my carbon, and then I'm going to put my oxygen. And remember, I have to start with at least 1 bond in between them, because in order for an atom to be connected, it has to be bonded to another atom. So there's my carbon and my oxygen, but again, it said I needed to use 3 bonds. Now, what you can't do in Lewis structures is you can't just put a bond out here bonded to nothingness out here. Okay, you can't do that. So what you actually have to do is we're going to have to use something that's called a triple bond. And this is as high as it goes. You can't have a quadruple bond. You can have a triple bond, though. So a triple bond means that I have 3 bonds, and so that means a total of 6 electrons in between that carbon and that oxygen right now. So I've added in my number of bonds. Now, here's the issue. Remember how I was talking in the last problem, how carbon wants to bond 4 times and oxygen wants to bond 2? Guess what? Both of those rules are going to get slightly broken, and this is what we would call is an exception. In science, really what Lewis structures are is they are models. They are our best way to represent how atoms behave and how molecules behave. Well, sometimes those models that we've come up with don't work all the time. Now, you might be like, well, how do I know when it's going to work and when it's not? I'm not going to purposely give you molecules that would cause you to get problems wrong. I won't give you the exceptions, but I wanted to show you that they exist. So what I'm going to do right here is I'm just going to leave these 3 bonds here and just kind of let it go, even though I know that carbon wants to bond 4 times and oxygen only wants to bond 2 times. I'm just going to leave those 3 bonds because that's how many I needed to use. But now I need to get rid of my 4 non-bonding electrons. Notice how both of them, okay, I'm going to use my colored markers again here. This carbon only has 6 electrons around it, and this oxygen only has 6 electrons around it. Because again, those 3 bonds in between them represent 6 electrons. So each one feels like they have 6. So what that means is I need to add 2 more electrons to both of them, so that way they can feel like they have 8, which means my Lewis structure should look something like this. And there would be the Lewis structure for what would be called carbon monoxide. Okay, so those are your examples. Again, if you have any questions, make sure you let me know. Thanks for watching.